Hello dear listeners, I would like to present you a report on the topic estimating degradation of strength of neat PEEK and PEEK CF, laminates under cyclic loading by mechanical hysteresis loops. In this work, a DIC-based method was employed for assessing the fatigue, induced degradation of mechanical properties of neat Polyetheretherketone and its laminated, composite reinforced with unidirectional carbon fibers. Its operation principle is based on the remote measurement and calculation of the maximum and minimum strains in a cycle, as well as both dynamic and secant moduli estimated from mechanical hysteresis loops. It is shown that these parameters reflect the degree of material damaging enabling to predict its current mechanical state. Polymer composite materials are increasingly used in the aircraft industry due to their both specific strength and corrosion resistance. Recently, interest in the design and application of PCMs based on high-strength thermoplastic binders, high-performance polymers, has grown significantly. On this way, in addition to solving the key technological problems of their fabrication, the task of estimating current strength properties is topical primarily under cyclic loading, since that is extremely important to reveal the development of localized inelastic strains caused by scattered damage, accumulation, and micro-cracking in PCMs. During cycle load, the issue of implementing such research methods is relevant. Mechanical hysteresis loops, which are one of the key characteristics of fatigue failure, can change their both shape and parameters depending on the material microstructure. That enables their use for analyzing the behavior of structural materials, including PCM, during fatigue testing. Two kinds of materials were investigated. 1. Neat PEEK samples. 2. A laminated composite based on a unidirectional tape of carbon fibers with a quasi-isotropic and symmetrical set. Mechanical tests consist of static, tensile and fatigue testing. The recorded load-unload diagrams were the basis for drawing mechanical hysteresis loops for both neat PEEK and its laminated composite, allowing to evaluate their mechanical properties. The slide shows characteristic patterns of UI strain component distribution and typical dependencies on the maximum and minimum strains, and the dynamic and secant moduli versus the number of cycles. Shown that the development of damage is accompanied decrease in rigidity and development of deformations. Conclusions. The deformation behavior of both neat PEEK and its laminated composite reinforced with unidirectional carbon fibers was studied under cyclic loading using the DIC method and the calculated parameters of the mechanical hysteresis loops. In these cases, the materials were characterized by different fracture patterns. For neat PEEK, under cyclic loading, with load control mode, there was a significant development of cyclic creep, which was the key fatigue failure mechanism. In contrast, the sample elongation was dominant for the damage accumulation of the PEEK CF composite. The parameters of the mechanical hysteresis loops calculated by the DIC method as quantitative characteristics of property degradation showed satisfactory sensitivity to the development of various deformation processes, primarily creep and damage accumulation. Thereby, the DIC method can be effectively implemented for in situ monitoring of the mechanical state of both ductile neat polymers and their rigid fabric, or unidirectionally reinforced composites.